Okay, number 5. We've got big A, little B, little c, crossed with big A, little B, big C, big C. I'm trusting that you guys are pausing this video so you can read questions or work on stuff and think and everything, because I'm going fast, and I'm really going faster than you should be able to do all this stuff without stopping. So be responsible. Alright, so if these are the parents, what's the chance that at least two, so it could be A and B, it could be A and C, or it could be B and C. So at least 2 of the traits are going to be dominant. Okay? Actually, that's part B of the question. So part A of the question is what's the chance of all 3 of them being dominant. So being dominant, if we look at them just A's, then we look at just B's and just C's. With the A's, you can have AA, or you can have big or big little, right? What's the chance of getting that? When you cross big little with big little, 3/4 are going to be big A something. That blank means that it doesn't matter whether it's big or little. Okay, so we have 3/4 for the A's. B's, we have big B crossed with little b, little b. Again, you should be able to do this in your head, but if you can't, then go ahead and cheat and figure it out. Big, little. And remember, since this is duplicated, you really didn't even have to fill in that line. So that would be 1/2 would be the chance of having the dominant, right? Big B, little b. There's no way possible to get big B, because that one doesn't have a big B. So anyway, this is going to be 1/2 for big B. And then for C, every offspring is going to have a big C because this parent here only has big C's to give. So all of them are going to be, so that means we're going to have 4 out of 4, which would be 1, right? So these are all the different things. Now they all have to happen at the same time. So what do we do if they all have to happen at the same time? Do we multiply or do we add? We multiply. So 3/4 times 1/2 times 1, and y'all remember how to do the math here. So you're going to get 3/8 as your chance of getting all 3 showing the dominant phenotype. Alright, cool? The second way was the question, at least 2. Yeah, at least 2 showing the dominant trait. So in that case, we're going to have more options here. Because we could have this, because that's at least 2, it's all 3 of them. Now remember that big C, little c is going to have to be a case. So we're not even going to have we don't have to do as much math is what I'm saying here. We could have big A, not a big B, but a big C, and we could have no big A's, a big B, and a big C. So we have all 3. We have A and C, and we have B and C. Am I forgetting anything? You're not going to have just A and B and little c's because you can't have 2 little c's in this case because this parent has to give the big c's. Got it? Okay, so what's the chance of having big A, little a crossed with big A, little a? That's going to give you 1/4 big, 1/2 big, little, and 1/4 little, little. So you add the big to the big little, and that's going to be 3/4. Okay? The B, big B crossed with little b, big little crossed with little little, to give you big B anything. So that's going to be 1/2. And again, if you have to do Punnett squares to get more comfortable with this as you go, then go ahead and do it. And then C's, all of these are going to have a big C in something, so that's going to be a 1. Alright, so that's going to multiply out to 3/8 for that one example. This example, we've got 3/4 again for the A's. For the B's, we've got 1/4. Oh no, that's wrong. For the B's, we've got 1/2 because you have this or you have this, and these two are the same. So little b, or big B, little b. So that's 1/2 again, and this is the same, so that's going to be times 1. So this is also going to be 3/8. For the little a, that one is going to be 1/4. Big little cross with big little, only 1/4 of them will be little. For the B's, that was 1/2 up here. And remember that's going to, whoops, that should have been a line, even though it would be a little c, times 1. So that's going to give you 1/8. Now, we multiplied because you would have an A and a B and a C all at the same time. However, you can't have this whole genotype and this whole genotype and this whole genotype at the same time. You only would have one. So now we're looking at multiple ways to accomplish the goal, which the goal was to have 2 or more dominant genes here, or dominant phenotypes. So now we add these together. So 3 plus 3 plus 1 is 7/8. So the chance of having at least 2 dominant is going to be 7/8. Alright, if you don't understand, rewind and watch again. We are going to skip 14.6 and 14.7 and 14.8 for today, and we'll come back to that on Monday. So go over to 14.9.